Hey, if you're joining me, I'm going to give it a minute or two before I go ahead and get started with building Tetris in PowerApps. In the meantime, I do have the chat window pulled up. It's on my second screen over here, so I can see the chat as it comes in. So if you have some questions before we get started, I think this is a good time to have a chat. All right. Let's see who's viewing right now. If you want to say hi in the chat window. We'll go ahead and get started in another minute. Hey, if you're just joining us, we'll go ahead and get started right now. Today, my goal is to build a Tetris app inside PowerApps, and I've set up a few things to go ahead and do that. I really haven't made this out yet, but I've thought about every way that I would make a game in Tetris. Before I do get started, I want to share a few things that I had learned yesterday. I was on a random call with Ahmad Musa from the Microsoft Premier team in Dubai, and he really helped me figure out why he really helped me put into words why I'm even making this video series on creating some games in Power Apps. Um, well, the first thing is when you choose to create something in Power Apps, you can't be worried about if something can be done or how it can be done in the moment. When you come up with ideas, you just need to put it down so that you can get started. Otherwise, you're going to be your biggest naysayer. You're going to feel like you can't do something. And really, this video series about building Tetris is not really about building a game, but it's about selecting a challenge, selecting a good challenge that you're passionate about. It's about picking something that you're so motivated to solve that you're going to be learning something along the way. Games are very motivational to make, so they make very good subject matter. When you're building a game, each requirement that you put inside the game is something that you're actually going to be learning. Um, so this is why I like to make games inside Power Apps. I've learned a lot from making them. So let me go ahead and start sharing my screen. And as people roll in, I do want you to understand that this is I'm going to be streaming for about like an hour. I'm not really sure if what I make is going to make it all the way through, but we'll build out as many parts as we can, and we'll pick up from where we left off next week. Let's go ahead and share my screen now. All right. So I am now presenting. First thing I like to do is just get a feel for Tetris. So I'm gonna search for Tetris and see what my requirements are. Okay. So I'm gonna pull up this Play Tetris for free and just remind myself of what I'm actually going to be building. Okay. So I know that it's got a grid. It's got some different shapes, and the shapes fall down. So I know I'm going to need some collision detection, just like I did in Space Invaders. Okay. Now this one uses the mouse. Okay. It has a certain size grid. and you're able to slam a shape down when you're satisfied with it. Okay. There's a score part of it. You can cue the next shape. Okay. So what I need to know is the size of a Tetris grid. So I'll go ahead and search for size of Tetris grid. So it's about 10 by 20. Okay. I'm going to jump over to OneNote here, and I'm going to show you kind of where my roadmap is on building this app. You know what? There's one more button I forgot to press. It's the present to everybody. Sorry for, sorry that I forgot to push that again. All right, here we go. So this is the design I'm thinking of. I'm gonna have this 10 by 20 grid, and each part of this grid is going to have an identifier. The first row, the second row, all the way to the 10th row, and each row is going to have so that's each of the columns, and each row is going to have an identifier. The first row, the second row, the third row, all the way up to the 20th row. Okay, so this is my actual grid. This grid is going to be where I show stationary objects, each of the squares that falls down. And then I'm going to have another layer on top of that. This is going to be the one where I have falling bricks. So this is the static one, where I show the bricks that have fallen. Okay, so I might have a shape like the Z kind of shape or the S kind of shape one. And when it encounters one of these stationary shapes, I'm going to have some collision detection. So this is the line of collision that I'm going to detect. So here is the static one. And here's the one that's falling. In order for me to detect this, I'm going to look for an inequality. When the location of this point right here passes the point here, that's going to be my collision detection. I'm probably going to use a toggle for that. Okay, so I know I'm going to need like some kind of table that has all of these records. I'm going to have like another collection of all these falling bricks. Other things I need to know, I'm going to have that toggle. I'm going to have a timer. I'm going to have a timer for the falling bricks. Okay, let me put down these as requirements. What I like most about OneNote is this checklist feature. So I'm going to have some falling bricks. Okay, I'm going to need to use a timer to animate the falling brick. I am going to create a table of the Tetris grid. I'm going to create collision detection for one square. Let's do one square falling. Once I get one square falling, scale out to an entire Tetris shape colliding. Okay, so I want to create falling bricks. I want to use a timer. I want to create a table at the Tetris grid and create some collision detection. Okay, let's see how far we can make it for here. I'm going to jump over to, let's see, where's my app? Started a blank app here, and I think it's probably best if I start with my OneNote or creating my table. Here I'm going to create a table like I have for here. I want to tell it the rows and columns, and I want to give each of these parts of this grid a unique identifier. Okay, so I'm going to have an ID column, an X, and a Y. Okay, so for the X, for each of the columns, I'm going to have 10 columns, and I'm going to have 20 rows of this. So row one is going to have these 10 columns. Row two is going to have the same. Okay. Repeat that for 1 to 20. Go ahead and get started so that you can see what's going on here. Okay, I'm going to repeat that up to 20. So let's do 3 here. That's row 3 with 10 rows, row 4 with 10 rows, row 5 with 10 rows, row 6. And I'm going to copy this again. Okay. 7, 8, 9, and 10. Okay, so half my grid is complete. I'm going to copy this whole thing. Okay. Now I want to make it this thing plus 1. And I'm going to make that static. Okay. I have 20 rows with 10 in each. Let's finish this out. Should be 200. Okay, so here's my Tetris grid. It'll make a little bit more sense when I bring it into PowerApps. Okay, I'm going to save that to some static data as static data for my apps. Tetris grid. Okay, jumping over to my app. I'm going to insert that data source as static data. Okay, I've stored it here. There's my Tetris grid. Okay, you know what? I'm going to cancel that. I'm going to give this a more descriptive name. We'll call it Tetris grid. Okay, and there's one more that I'm going to put in here, the status. This means, is there currently a block here inside Tetris? By default, I'm going to have everything false. Okay, now let me go ahead and add that again. Okay, I'm going to select it. There's my Tetris grid. All right, let's go ahead and create that first gallery just so you have a better idea of where I'm going with this. Okay. I am going to bind this to Tetris grid. Now, from the Space Invaders app, if you had seen me make that one, I used a template size of 0. And the reason why I wanted to do that is every single Space Invader that's inside that grid of Space Invaders is going to have a unique location. And having that unique location is going to be used for detecting if an object has collided or not. Okay, so I'm going to include a label here. This label is going to be my brick, my block. Okay. I'm going to turn this Tetris grid so that it has all of those so that it's lined up like a grid. Okay, I'm using the slider to determine what's the best size for this Tetris grid according to the size of the screen. So I'm thinking if I take that gallery and I take its width and divide it by 10, that might be a good size. Or if I take the gallery's height and I divide it by 20, I think that would be a good size as well. Whatever fits best. So I use the minimum function to do that. Okay, now that I have that size, I'm going to set this label to that size. Slider 1.value. Okay, now it's a square. And I'm going to turn this gallery to that same size as well. Okay. And then, and turn this template size to 0. See that things start to stack up? Okay, now we're going to do some sizing here. I want to place this label where it should be placed. Okay, right now the X value is at 0, so they're all lined up against the left edge. So what I want to do is I want to line it up so that, just going back to our table here, so that objects that are in that first column are lined up in that first column. So I'm going to take that X value. I'm going to subtract 1 from it. So the first one in the column is going to be at position 0. And multiply that position by that slider value. So now the first one is in that first location, the second one is in the second location, and so on. Okay, I'm going to do the same thing for Y. Take its Y position, subtract 1 from it, so that the first value appears in the first area. Okay, and then I'm going to multiply by slider 1.value. Okay, now you start to see it starting to line up in a grid. I'm going to compensate a little bit. You'll see that things are not lining up exactly. It's because PowerApps adds 1 pixel for every record inside the table, inside the gallery. So I'm going to subtract 1 for every ID number. Okay. So ID number 1, I don't want it to subtract any pixels. ID number 2, I want it to subtract 1 pixel, and so on. Now it's starting to line up. Okay. Let me make this size, the font size smaller here, so that I can see the numbers. Okay, so here's my grid of Tetris. Let's go ahead and change that text to the X and the Y. Okay, so those are my X coordinates and my Y coordinates. All right, the first gallery is ready. My grid is ready. Okay, I'm going to create a gallery for the blocks that fall down the screen now. I'm going to make it the exact same size. And I can go ahead and set all of its dimensions to gallery 1. I think this is a good time to rename things. So we'll call this the first gallery, the original one, the grid, the gallery of the grid. We'll call this second gallery the gallery of the blocks, of the falling. Just call it blocks. The slider is the block size. Okay, I'm going to save my progress. All right. Now let's continue. Before I populate this, this gallery of blocks, let's give it some sizing. I want its width to be gallery grid dot width. In other words, give it all the same dimensions as that first gallery. Same height, same position, and the X and the Y. Okay. For both of these galleries, I'm going to set the scroll bars off so that they don't show up. All right, now for the gallery of blocks, the ones that are falling, let's go ahead and create a fake block. I'm going to collect from a gallery of blocks, or collect to a collection of blocks. Let's have some columns here. An ID number. Take the maximum ID number in the blocks collection. Add 1 to it. I want to have a row. I have a column. The column. Blocks that are falling in Tetris, I want them to start off in the middle. What I could do is I could go ahead and even use a slider to tell to tell this collection where to place the block by default. So here I'm setting up a slider from 1 to 10. And by default, I'm going to have these blocks fall down in column 5. Let's set this to slider value so that the blocks that fall are going to fall in column 5. Okay, now the row number, this is going to be a relative value. In Tetris, the blocks fall from the top. I'm going to have these blocks start at row 0, somewhere up there. And see what else we need. I think that's it for now. Okay, I'm going to create a block that falls at that speed. Okay. Going into this gallery, I'm going to set it up the same way. You can turn off the template padding to 0. I will insert I'll insert a label to show this block. Okay, I'm going to set this gallery items to blocks. Okay. Now, this block that's falling, use almost the same formulas here. Take its row value or its column value, subtract 1 from it. I'm going to multiply it by the size of the grid, of each of these grid squares. Slider block size dot value. Okay, so I want its x to be starting there. I want its y to be starting at the row. Take its row, multiply by. I want this block to be falling, so I'm going to have it. Let me redo this. Have it start above this gallery. Okay, so it starts above the gallery, and then I want it to add the height of this gallery. I want to add the height of the gallery as a timer is progressing. So let's insert a timer on the screen. Okay, this timer is going to show us, going to be used for having this block fall. Normally, the block takes about like 3 seconds to fall from the top to the bottom. For our testing purposes, let's make it fall within a second. So 1,000 milliseconds. Okay. All right, going back to that gallery of blocks that are falling. It's going to add this height as the timer progresses. Okay, so it starts at this location above the gallery, and then it adds the gallery's height, and eventually it gets to the bottom. Okay, let's make it compensate a little bit for its kind of like what we did with the other one. Take its ID and subtract it. Okay. Shouldn't affect it too much. Okay, so we're going to need to give it a width and a height. Let's give it slider block size dot value. That way it's the same size as the grid. And its height. Okay. When I insert a block, I do want it to reset the timer. Okay. And I want this timer to start automatically, as long as there's a block. So I'm going to use is empty. As long as blocks is not empty, I want it to automatically start. Okay, let's see how this is going so far. One more thing I want to do. Let's give this some color. Let's insert a block. It fell into column 5 here. Okay. All right, so the blocks are falling. Let's go ahead and clear that. For right now, I'm going to insert a button where I will clear the blocks. Let's go ahead and give this a more descriptive thing. Create a block. Okay, so I create a block falls in the column that I want. All right, now we need to configure a few more things. The gallery of blocks needs to have a template size of 0. Okay, now it's working. All right, we have gallery of the grid. We have the gallery of the blocks. Let's go revisit our table here. We have a table. We have a timer for animating the falling blocks. We're going to need to create the collision detection now. This is pretty much all of Tetris right here. I'm going to go into, let's see. I am going to go into my gallery of my grid, and I'm going to insert a toggle. I like to use toggles because they can flip on and off depending on the conditions that I set. Let's go ahead and place this toggle at the same position as the number there. So I set it to label 1.x, label 1.y. Okay, so now each of the toggles is lined up. Bring the label to the top just so I see that number. Okay, in the default property of this toggle, I want this toggle to flip on, and then I want it to stop all of the blocks that are falling. So I want to detect the location of the falling block. All right, here goes. This is the hardest part. Here's my logic. I think what I'll do is I'll create yet another gallery. You can't have enough galleries inside PowerApps. Okay, what I want to use this gallery for is detecting, what's the bottommost point? What's the, or what's the highest most point in each column? That way, I know if something can be a collision point, because not everything in here is going to be a collision point. Okay, so let's filter the grid. Tetris grid. Oh, you know what? Since we're going to be updating the Tetris grid, let's change a few things here. Okay, let's make that table Tetris grid that we made into a collection. That way we can update the status. Because right now, it's a static data source. It can't change. So I'll clear collect. Call this grid Tetris grid. I'm going to get everything in that Tetris grid into this collection. Which means I'm going to go into this items property and I'll set it to that collection. Okay, So if I filter that grid for all of the ones where there's not a brick, oh, status is false. Hmm. Okay, so I want to pick the spots on the grid where there isn't already a brick, and if it's a collision, it should be a collision point if it's the bottommost one. So if its y value is 20, and if I search the rest of the grid where uh, that's in the same column, okay. If I search all of the bricks in the same column, and there's not already something in there, oops. If there's not already something in that column, then I want the collision point to be this 20th record. Otherwise, I'm thinking that I want the collision point to be the smallest one in each column. So if I were to search the same column here, and I looked for the smallest row, the smallest one in that column should appear here. Okay, I think I got that logic right. Okay, I'm going to change a few things here just so it all fits. Okay. Let's show, okay, so here's the ID number. Let's see what are the possible collision points. Here's the X value. Okay, so and here's the Y value. Okay. Um, it should be appearing as 20 here. Let me check my logic. If the Y equals the smallest one, if the Y, I want it to be 20, but if there's a brick inside 20, I want it to be 19. Ah, okay, I know what to do. If is equal to, if lo- if the column is equal to the smallest y in the column, I know. Look at the ones that are completed. Subtract 1. Okay, if it's equal to the smallest one in the grid in the same column that has been completed, subtract 1 from it. Mm, let me think. I think I'm almost there. What I'm trying to figure out is the collision points for each of these. So if it's the smallest one, if I look at all the ones in the same column that have been completed, look at its column, look at what row it's in, subtract 1 from it so that it's right above. If it equals that one, then stop it. Hmm. What if I get rid of this? Oh, I am stuck for a second here. All right, let me check the chat window. Any thoughts? What did I do wrong here? If I look at, if I search, if I search for the smallest one in the column, and I subtract 1 from it, hmm, I don't think I need this part here then. And wait a sec. Okay, so I understand it now. If you look at all of uh, the blocks that have fallen to the bottom already, and there's none of them, then 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 it's okay to make it land at that 20th spot. If otherwise, make it fall to this spot. Make it fall to the one right above the ones that have fallen already. Okay. Let's. Okay, I understand a little more now. Okay, so these are all the possible collision points. So that 20th row, I'm going to use that. Let's call this collision. Gallery collision. I'm going to go back to this toggle that I've set up. Now I know the possible points for collision. If if this ID number is in that gallery of collisions, one of these, all items, ID. If it's in this column right here, okay, so all the bottom ones are ringing true. Okay, that's going to be my first condition. All right, things are going to get complicated now. And now I need to check for the height. If I filter the blocks that have fallen, so I look into the gallery of blocks, I go in there and I look at all of the blocks. I look at all of the blocks. Let me think. I want to compare the heights. Okay, if I look at the height of the block right here, this label 1, I look at the location of this. This y value has been surpassed by this block, then flip this toggle true. Okay, so that's my logic. Comments here. So this part especially needs comments. Okay, check if this block, this part of the grid is a possible collision point. If the if give me some names. It's the falling block. the grid location. Save what we have so far. Okay, so here's what I'm thinking. I want to check if that grid location has been surpassed. I'm going to go into that toggle. If this position is less than or equal to the height of this, the y value of this falling brick, I'm just going to copy this whole thing. If its location in the grid has been surpassed by this thing, and flip the switch on. So as long as this is not empty, flip the switch on. If there is a block that there's a falling block that has exceeded the given location in the grid, flip the toggle on. Okay, let's play this and see if it works out. Okay, 1 second. I'm going to need to compensate. You see how some of those toggles triggered a little bit early? It's because in this grid location, we compensated a little bit for this, for the ID number. That was just to be graphical about it. Let's uncompensate for it by adding that amount. Okay. And for our purposes, let's comment out this condition up here. I just want to see. Oh, okay. Just want to see that the falling brick is activating the right toggle. Okay, so the toggle, if it's past, so this falling brick has passed all of these locations. Okay. Now let's narrow it just to that column. Okay. There's a falling, toggle it on. Check for blocks in the same column. Okay, so only look at the blocks in the same column. Check for falling blocks in the same column as this grid location. Okay, so what does that look like? If this x equals, oh, easy. If the x equals the column number, and if the y has been passed, then make this true. Okay, and one more thing I'm going to do. Okay, so I have this falling brick. It has passed all of these locations. Oh my God, that is beautiful. Okay, let me add another brick. Let's do it in the 4th location. Okay, let's make a brick fall in the 7th column. Okay, so we have the minimum requirement here. We have a brick, and it's hitting. We're detecting that it's surpassing these areas. Okay, let's put another condition on top of that. I only want it to activate if it's one of the possible collision points. So only this last one will be activating now. Okay, let me check that one more time. If it's one of the collision points, I think I know what to do. Let me do this in a picture. The block that's falling, let me show it over here. The block that is falling, we're comparing this location, this Y location, against this location. I want to add this amount. So the height of that brick. Okay, so let's compensate for that. Okay, so I add the block size. This might just be an issue with the inequality. What if I subtract 1 here? I didn't see the toggle trigger at the bottom. I think it's because it's too low. Okay, now I see it. There's a little bit of blue there. Okay, when that toggle's true, now let's give it some actions. Okay. So I've detected the collision. When it's collected that collision, I want it to go into the grid, that particular item, and bring its status to be true. In other words, make it visible on the actual grid. Okay, so this will right now. Let's make this grid location only appear. Make it only appear when the status is true. And there's a lot going on the screen here. So let's only show this if this item, there's an item falling in this column. If this item dot x is in the falling blocks, okay. There's a falling block. Oh, what's going on here? Oh, I made it do some. I didn't finish my actions, so it's triggering everything. Okay. Then, after it brings that thing true, let's go ahead and remove those blocks. Reset this. Boom. So it got rid of that block, and let's give that block some color. Okay. So this block is stationary now. I have a falling block. Boom. It's stationary now. Oh my gosh. Okay, so the basic components of Tetris are being made right now. What if I go in the 6th? Oh, let me bring a block to stick a block in the 5th column. Okay. And a block over here. Oh, wow. All right, so let's go back to our requirements here. I detected the collision for 1 square falling. I scaled out, let's see. 1 square is falling and it's detecting the location. Now, what if I send down a Tetris shape? Okay, I want them to save. I want it to to detect the collision and save all of the things that fall. Okay, so let's make some other squares fall here. Repeat this. Right now it's sending a brick in column 5 or the column that's selected, the number that's selected here. Let's have it send two of those. One of them is going to be in the column next door in the same row. Okay. Let's do a square. Um, okay, so I'm going to have this one in row -1, so above the location. And show it here. So let me just show this to you so you see where I'm going. Okay. Notice it only fixed the it only saved the static location of one of those squares that fell. Let me check my squares again. I don't think I did that correctly. Okay, the blocks that are falling. Okay, they're all falling. Two of them. Okay, so two of them are falling on the 0th row. Two of them are falling on the row above that. And then two of them are falling in the given column, and two of them are falling in the column next door. I know what to do. The falling block, we need to compensate. Right now it's above the gallery. Let's also make it compensate for the row. I'm going to take this item.row and multiply. So it takes the row number, 0 in most cases. It's going to add the size of the block if it's in a different row. If the row is -1, it'll subtract another size of that block. So if I were to create a block, there's a square that's falling. Okay. You know, a square is kind of boring. Let's do -1 and 0. Okay, let's do this T shape. Okay, I think this is more interesting. Okay, when it detects any of those falling, when it detects any of those things falling, I want it to stop all of those shapes and write them. Okay, so let's detect that. All right. Need to figure out what this is. Make a when collision is detected, then when collision is detected, make the corresponding square, make the corresponding location in the grid here. Okay. Now we need to detect what is the collision point? So determine the point of collision. So I've got that T-shaped thing. I only know the block right ahead of it that collided. Let's figure out what that block is. So look, let's call this a collision block. The block that collided. The block that collided is going to be in the same column. So if I look inside the blocks, and the column is this item dot x. Okay, so it's in the same column. I want the one that has the highest row number. So the row equals the highest row number. So look inside. So I'm going to look inside the blocks for in the same column. And look for the biggest row amount. First one. Okay, so the block that collided is going to be the one that's in the same column and the biggest row in it. So row 0, I guess. Row 0 typically. Okay, so I know my collision point. Okay, let me draw what I'm thinking here. Let's say this is collided. This is the one that's collided. I know my collision point, so I want the blocks around it. I want to determine what those are. Let's identify those. Okay, identify them. And stop them as well. Okay, so bring the reset value to, not the reset value. Bring their status to true. So find out what they are. Okay. What did they collide with? Let's see. Set. What did they collide with? Call it the collision location. Collision location is going to be this item. So I know what block collided, and I know where it collided. I'm going to take that information for all the blocks. All of the blocks. Go into, look inside the grid. Inside the grid, where look inside the grid where it's in the same column. Okay, let me draw this out so I understand it better for myself. Okay, so here's the point of collision. This is collision. Okay, so there's the point of collision. If the point of collision look for the one in the same. Oh, each of these already has a column. This is like column 4. This is column 5. This is column 6. So they already have a column number. Okay. So if the column number inside the grid for the matching column number, but this one up here is row -1. This is row 0. This is row 0. So here's the point of collision. If I take this square and I know what it is, I know where it collided, I make it add 0 or -1. I add, what do we call that? The row. Okay, so if I add the row, I look for the y where it equals the collision block dot row. It equals the collision block plus what it's compensating for, which is row. Okay, so I think I've identified the right one. Turn its status to true. think I got it. For each of the blocks for each of the falling blocks, look for the corresponding location in the grid and reveal it. Oh gosh, okay, I think I got this. So if I create this block, this thing is going to fall and I should see all of these appear. No, it didn't go. Let me think, what else do I need to do? Okay, so why didn't they activate? For everything inside the grid, for each of the blocks, look inside the grid in the same column, match the Y where the collision location, the location of collision, let me think, the location of I know. It cannot be activated already. Cannot already be activated. See if that makes a difference. I drop this block. Nope. Let me think. I want it to stop all the other parts as well and make them appear on this grid. And once I do that, oh, it looks like, okay, I'm not that far off. Okay, I just need to figure it out. Let me think. So close. I'm thinking if I, I don't think this will make a difference. How are you going to bring it? Oh, I know what I'm doing wrong. I need to compensate it for the collision location. I'm making it look for the wrong spot. Collision locations, my value. Okay, let me see. So if I make this thing, make a block fall. Whoa, wait, let me do that again. Okay, so I'm going to drop something in column 6. It should stop here at 7. Boom. Okay. All right. We're right at time too. I'm going to keep dropping this. All right. I think I'm satisfied. I made this block fall and it's able to stop there. Let me just do 5 here. And then 4. So it's detecting the exact spot. Oh, wow. That is cool. And then it should stop there. Okay. I think I'm satisfied for now. And then I'll continue building out some more next week. Like detecting there's 10 in a row. Let me switch screens here. Okay, so those of you who are still on the line, let me check the chat window on my other screen here. I think what I'll do is next week, when it's the weekend again, I'm going to build out detecting like 10 of those blocks in a row. And then if there are 10 in a row, eliminate them and then make everything else drop down. I'm thinking of generating the next Tetris block that falls and different kinds of shapes. So like the square, the S shape, the long stick. I think those would be good next steps. Let me write these down. Next steps. Okay, so would include create queuing, different shapes, Tetris shapes, detecting 10 shapes, 10 blocks in a row, and eliminate 10 blocks in a row. Drop everything above the detection of 10 blocks. So drop that much. Okay, so these would be good next steps. Okay, well, big idea is before I let you guys go, is my goal with this is not just to make a Tetris app, but to show you what am I doing when I get stuck, especially when I'm trying to figure out this collision detection. Drawing things out is helpful, and looking at things inside this Excel table, having an Excel kind of mindset, that grid kind of mindset helps me figure out this Tetris app. Well, thanks for joining me, and catch me next week. I'll schedule something in advance so that you can look forward to this next weekend. All right, have a good weekend.